Have you ever wondered if there are more natural ways to lower your high blood pressure, guard against Alzheimer's, lose weight, feel better? Well, it turns out there is. Welcome to the Nutrition Facts Podcast. I'm your host, Dr. Michael Greger. Today, we look at boosting our GLP-1 the way Mother Nature intended. Plant-predominant diets may play a major role in reversing the obesity and chronic disease epidemics, just as plant-based dietary interventions may arrest or even reverse type 2 diabetes and cardiovascular disease on an individual basis. In a previous video, I showed how a tofu burger boosted levels of the appetite-suppressing hormone GLP-1 higher than a meat burger in both people with diabetes and without, even though the two burgers were matched for calories and macronutrients. One thing may have given the plant-based meal an edge, though, at least over time: increased fiber. The bacterial fermentation of dietary fibers in the colon produces short-chain fatty acids called acetate, propionate, and butyrate, which in turn stimulate release of GLP-1. In this way, prebiotics like dietary fiber represent an alternative strategy for boosting production of GLP-1. In contrast, a bacterial breakdown product of tryptophan, which is concentrated in animal protein, has been found to have opposite effects on GLP-1 release. How do we know fiber-derived short-chain fatty acids boost GLP-1 in the first place? Well, all three circulating short-chain fatty acids were associated with higher GLP-1 concentrations in the blood, but that doesn't prove cause and effect. For that, you need to stick tubes in people's butts. Getting a rectal infusion of acetate indeed causes GLP-1 levels to go up, and the amount of acetate concentrations in the blood reached after rectal infusion were within an achievable range, in the ballpark of what you get eating 15 or more grams of fiber a day here in the form of oat bran cereal and muffins. There's a third way to get appetite-suppressing short-chain fatty acids in our bloodstream, besides the top-down approach of eating healthy food and the bottoms-up approach of getting them squirted in your tush. When you consume vinegar, its acetic acid is rapidly neutralized into acetate. No wonder vinegar has evidently been used to treat obesity for centuries. Does this all translate into reducing cravings, eating less, and losing weight? Let's scan people's brains and find out. Researchers delivered propionate, fiber-derived short-chain fatty acid, into the colons of study participants while showing them images of pizza, cakes, and chocolates, and found that increasing colonic propionate seemed to reduce brain activation in the reward centers of the brain. This was accompanied by a decrease in subjective appeal of these kinds of foods. They didn't look as tasty, and this translated into reduced caloric intake at a buffet meal. Note that this effect didn't seem to correlate with GLP-1 changes, though, so it's possible that short-chain fatty acids produced in the colon are accessing the brain directly and reducing appetite some other way. Regardless, does the boost in GLP-1 and the short-term reduction of caloric intake from the direct delivery of propionate to the colon translate into better weight control in overweight adults? Yes. Long-term colonic propionate delivery prevents body weight gain, particularly deep abdominal fat, and may even reduce liver fat in those with fatty liver disease. So you'd expect prebiotic trials to show the same, and sometimes they work, boosting GLP-1 and driving down hunger. But overall, human interventions with prebiotics have shown mixed results, and that's putting it lightly. Effects on GLP-1 appear to be highly contradictory, with different isolated dietary fibers bumping GLP-1 up, some dropping it down, and others having no effect. In some cases, it's possible that macronutrients that would otherwise stimulate GLP-1 might get caught up in viscous fibrous masses and result in lower levels regardless. Results for short-term prebiotic trials are said to be completely inconclusive for GLP-1. Well, one problem may be the dose. For example, researchers tested refined grain bread versus whole grain bread. Although the whole grain bread improved satiety, it had no effect on GLP-1. The difference in fiber content was only about 5 grams, though, which may not be enough. In this study participants were randomized to get either 5 or 10 grams of a fiber supplement called Fibersol, and the 5-gram dose appeared to have no greater effect on GLP-1 than placebo. Only the 10-gram dose worked, which is about 2 tablespoons. Similarly, there were significant delays in hunger and increased satiety after 10 grams, but not 5. And studies like this may only last a few hours. The more fiber-rich foods you eat, the more you foster the growth of more fiber feeders, which means even more GLP-1 secretion over time. Eating more fiber-rich foods may eventually even promote the emergence of more GLP-1 secreting cells in our intestinal lining. Check out this study. Adaptation of colonic fermentation and GLP-1 secretion with increased fiber intake for not a few hours, but an entire year. People who eat whole grains tend to get less diabetes, but even if you switch to whole wheat for weeks or months, there doesn't seem to be much improvement in blood sugar control. It turns out it may take longer than that for our colon to adapt to the increased fiber intake. Colonic adaptation to increased wheat fiber intake takes many months, but eventually results in increased short fatty acid production and GLP-1 secretion. This was found when people were randomized to a year of either All-Bran or Rice Krispies cereal for breakfast, and there was a significant increase in short-chain fatty acid production and GLP-1 secretion in the higher fiber group, but it took 9 to 12 months for these benefits to develop. And finally, people may not understand the complexity of dietary fiber, thinking that it's a single nutrient, but there are literally thousands of types of fiber in plant foods, and each one may support different communities of bacteria in our gut. That's the reasoning behind recommendations that people take a 50-food challenge, eating at least 50 different plant foods a week to achieve a diet diverse enough to feed a vast spectrum of bacteria. Those who get more fiber in their diet are significantly less likely to get heart disease and die from heart disease, less likely to get cardiovascular disease in general, and less likely to die from it, less likely to have a stroke, less likely to get diabetes and colorectal cancer, less likely to die from cancer across the board, and less likely to die from all causes put together. But all this is for fiber from food. In terms of fiber intake for optimal health, the first line of defense for disease prevention is to focus on fiber from foods rather than supplements. For the treatment of disease, there's a lack of evidence-based research to support the use of most isolated fiber types. Take that supplement Fibersol, for example. Fibersol is a registered trademark of the Matsutani Chemical Industry Company, the one who invented it. Looking to increase the fiber content of a finished product? Check out our innovation success stories. Eat your donut cookie whipped cream milkshake. It's got fiber. Maybe better to stick to foods that were invented instead by Mother Nature. The majority of cells producing GLP-1 are located at the end of the gut in our large intestine. But prebiotics don't represent the only slow digestion-oriented dietary strategy to sustain the secretion of GLP-1. Prebiotics can be used to promote metabolic health and longevity by stimulating intestinal production of GLP-1, and so too can the drug acarbose, which acts as a starch blocker, inhibiting the enzymes that would normally digest carbohydrates earlier in the small intestine. Acarbose-induced transfer of carbs to the lower parts of the intestine increases GLP-1 levels, and since changes in GLP-1 correlate with weight loss in those on the drug, it's reasonable to suspect that GLP-1 is a mediator of the favorable impacts of acarbose therapy on weight control. There's also a third strategy, eating lente carbohydrates, from the Latin lentus for slow. Instead of taking a drug to slow dietary carbohydrate digestion, what about just choosing a diet centered around slow-digesting lente carbohydrates to achieve comparable benefits? That's the theory, anyway. So that means pasta, beans, groats, meaning structurally intact grain kernels, as well as sprouted grains. Let's start with beans. Researchers found enhanced secretion of satiety-promoting gut hormones after the consumption of white bread that had been enriched with coarsely ground chickpea flour. And the more chickpea it contained, the higher the GLP-1 level spiked. But where are you going to find chickpea bread? What about just eating beans? Asking people to eat 5 cups of beans a week spontaneously led to health benefits similar to those seen after asking people to cut 500 calories out of their daily diet. But there was no change in GLP-1 levels. What about cocoa beans? I wish, but sadly no effect of dark chocolate on GLP-1 either. The one pasta study I could find also failed to bump GLP-1, but the one sprouted grain study I found showed higher GLP-1 response to sprouted bread compared to 4 other types of bread, which didn't differ significantly from each other. 11 or 12 grain bread was no different than white bread? That's what's generally found when comparing products made with whole grain flour to refined grain flour. There aren't any immediate right-after-the-meal effects of whole wheat bread compared to white bread, for example. You can't just eat bread and expect some kind of Ozempic effect, because, as I explained in my last few videos, food structure is critical for optimal health. When grains are milled into flour, whether whole wheat or white, their cell walls are ruptured, and the starch spills out and never makes it down to our colon, so we don't get their added benefit. This is one of the reasons former Harvard nutrition chair Walt Willett has argued that the term whole grain should probably be reserved for only whole intact grain kernels, otherwise known as groats, the holiest of grains. In my book, How Not to Diet, I talk about my Brol Bowl, a prebiotic mix that includes barley groats, rye groats, and oat groats. What effect might they have on GLP-1? If you give people bread containing some whole intact barley groats, there's no immediate difference in GLP-1 levels in the subsequent 3 hours, but the groats wouldn't even have had time to make it down to your colon that quickly. However, after your good bacteria have had a chance to break open their cell walls, you get a greater, higher GLP-1 bump more than 12 hours later at breakfast the next day. The question, though, is whether that translates into a suppressed appetite, and indeed, lower food intake, not just at breakfast, but also at lunch the next day, 14 hours later. Having barley kernels at an evening meal not only increased GLP-1 the next day, boosting blood levels by 43% at breakfast, but feelings of hunger decreased during the entire next day, and the research participants ate about 100 fewer calories of an all-you-can-eat lunch just because they had some barley groats 14 hours before. Eat barley groats 3 days in a row, and on the 4th day see a 56% increase in the level of GLP-1 in your blood. What about rye groats? Eat rye groats for supper, and more than 10 hours later, your GLP-1 levels are up, and your appetite is down. Researchers found that participants had an increased subjective feeling of satiety during the course of the entire next day, so rye groats demonstrate anti-diabetes and anti-obesity potential as manifested by enhanced blood sugar control and increased GLP-1 and the accompanying appetite suppression. And there was a correlation between the short-chain fatty acids acetate and propionate and GLP-1 response, suggesting that indeed we may have our good gut bugs to thank for the beneficial effects. The cells that produce the appetite-suppressing hormone GLP-1 response to calorie exposure are concentrated all the way down at the end of our digestive tract, which is why our appetites are not suppressed very much these days. The majority of calories we eat are absorbed early in our digestive tract, so never make it down far enough. When we eat a donut, its fat, sugar, and starch get absorbed quickly, high up, before reaching the part of our digestive tract where we produce most of the hormone that suppresses our appetite. So, from a GLP-1 standpoint, it's like we never ate much of anything. No wonder we reach for donut number 2. How can we eat a donut and still get GLP-1 activation? Surgery! Bariatric surgery can involve cutting out part of our small intestine, so some of the donut calories may reach the end of it after all. What if you want to eat a donut, still get GLP-1 activation, and keep your anatomy intact? Drugs! By injecting GLP-1 mimicking drugs like Ozempic, you can get GLP-1 activation no matter what you eat. You could also take the starch blocker drug acarbose to slow the digestion of carbohydrates, or the fat blocker drug orlistat to slow the digestion of fats. But what if you want GLP-1 activation without drugs or surgery? Well, you could try not eating donuts. Ancestral humans might have consumed as much as 100 grams of fiber daily. That's about 6 times what most of us are getting these days. We evolved eating massive amounts of whole plant foods, the only place fiber is found in abundance. So by eating the way nature intended, we can release GLP-1 the way nature intended, which helps explain why a whole food plant-based diet is one of the most powerful weight loss interventions ever published. But what do we do about our cravings? What are some therapeutic approaches to addressing them? Well, there are drugs, of course, but in terms of food-based interventions, there are thylakoids, which are just the chlorophyll-rich membranes inside leaves where photosynthesis takes place. Thylakoids act as fat blockers, delaying our digestion of fats and promoting the release of satiety hormones like GLP-1. When we eat thylakoids, In other words, when we bite into a leaf of spinach, for instance, the thylakoid membranes are able to resist our digestive enzymes. They can last for hours in our gut before finally being broken down, and it is in those hours when they work their magic. Thylakoids glom onto tiny droplets of fat in our digestive tract, and in this way powerfully slow our digestion of fat. And that means more GLP-1. Yes, GLP-1 is a hormone that's being developed as an anti-obesity drug. This was published 2 years before Ozempic. But thylakoids can cause our natural endogenous release of GLP-1, which is an easier, more physiological way to enhance GLP-1 levels to achieve satiety and calorie balance. But does it actually cut cravings? Spinach extracts were disguised in jam and juice to sneak thylakoids undetected into meals, and those unwittingly eating the equivalent of about half a cup of cooked spinach felt significantly less hungry and more satiated over the next few hours. Give someone the equivalent of a shot of wheatgrass juice, or what they might get in a green drink or green smoothie, and not only do they feel more satiated, but their cravings for sweet, salty, and fatty snacks, such as potato chips, chocolate, and cinnamon buns, drop by about a third. Feed them candy anyway, and those who unknowingly have been snuck some spinach report liking the sweets significantly less. The satiating power of greens has been attributed to their high fiber and water contents and low calorie density, but the thylakoids may be their secret weapon, presumably because of the increased release of GLP-1 following thylakoid supplementation. In a systematic review of randomized control trials on the effects of thylakoid intake on appetite and weight loss, hunger-suppressing effects of thylakoids were reported in all studies that directly measured hunger and fullness. But what about the weight loss? Would the GLP-1-induced reduction of cravings and hunger from greens translate into losing pounds? I showed how starting your day with a single dose of thylakoids increased feelings of satiety and decreased hunger and cravings for snacks and sweets throughout the day. We're talking about a powdered spinach extract equivalent to just a half a cup of cooked greens. Significantly less desire for salty snacks over the next 9 hours compared to placebo, with just 1 dose of greens. Significantly less desire for sweet snacks, sweetened fat, snacks in general. Thylakoids thus provide a powerful strategy to suppress the urge for so-called palatable food, potato chips, chocolate, cinnamon buns, and the like. But despite the lower hunger and greater satiety, food intake throughout the day was not significantly affected. In a systematic review of randomized clinical trials and the effects of thylakoid intake on appetite and weight loss, the hunger-suppressing effects of thylakoids were reported in all the relevant studies. But what about the weight loss part? Instead of a single dose of greens, what about the same dose every day for 3 months? The title gives it away. You get a loss of body weight, reduced cravings, and increased release of the appetite-suppressing hormone GLP-1. The average amount of weight loss was only about 3 pounds, but the study participants also got a significant drop in cholesterol, 20 points. The drop in cholesterol preceded significant weight loss, so the cholesterol benefit wasn't just because weight was being lost. And 20 points, that's the kind of result you get using an earlier class of cholesterol-lowering drugs. GLP-1 was also boosted by about 40%. And check this out, significantly lower cravings for sweets, even 11 hours after spinach intake. And remember, the spinach powder was hidden, so people didn't know which group they were in, didn't know if they were getting greens or placebo, and 11 hours later they were like, chocolate? No thanks. Got any spinach? So not only were there decreased cravings in the 6 hours prior to lunch, but also decreased cravings afterwards, all from just getting that one single dose of greens in the morning. That's the power of GLP-1. Now, one of the authors had a conflict of interest, affiliations with companies trying to commercialize thylakoid products, and you can see it in the spin. They describe the spinach extract as markedly reducing body weight, but I wouldn't consider 3 pounds markedly. They boast that the 6% weight loss was comparable to an older GLP-1 drug available at the time, suggesting that increasing the natural release of GLP-1 may be as efficient as pharmacological agents for the treatment of obesity. Of course, our new GLP-1 drugs can decrease body weight by more than 6%, but the 6% loss in this study was from baseline, not compared to placebo. Those on the placebo lost about 4% of their body weight, so weight loss attributable to the spinach was more like only 2%. And another 8-week study found no significant difference at all. So when they took their supplement to the European equivalent of the U.S. Food and Drug Administration to try to make a weight loss health claim, the panel was like, 1% weight loss? That's really not going to do much. Whether these appetite-lowering effects of thylakoids could be a useful strategy in controlling obesity in the long term is still ambiguous. More studies are needed, and here we go. The latest thylakoid weight loss study, a randomized, double-blind, placebo-controlled trial with that same dose equivalent to half a cup of cooked greens, and there was a significant decrease in body weight, fat mass, waist circumference, waist-to-height ratio, and body mass index, BMI, compared to placebo, and by a decent amount. Individuals in the Spanish group lost 15 pounds, compared to 7 in the placebo group, 8 more pounds of weight loss on greens than placebo, and that included 8 pounds of straight fat, including 4 more centimeters off the waist. So, based on a systematic review of the potential effects of thylakoids in the management of obesity, eating green can suppress hunger, reduce food intake, and result in weight loss. Greens can offer a means to strengthen our resolve to refrain from eating, especially when we're in a kind of high donut environment, where there's superfluous access to foods processed to deliver qualities that some may find irresistible. It's interesting, even supplementing a breakfast that was only 11% fat with thylakoids resulted in decreased hunger and cravings, suggesting that there might be other mechanisms for the appetite-suppressive effect of thylakoids beyond just slowing the digestion of fat. What's the best way to get them? Not from the supplement aisle, but rather the produce aisle. And remember, that's where the chlorophyll is found, so you can see it with your own eyes, which veggies have more thylakoids by how dark green they are. What happens when you cook greens? Blanched for 15 seconds or so in steaming or boiling water, they actually get even brighter green, but if you cook them too long, they eventually turn a drab olive brown. When greens are overcooked, their thylakoids physically degrade, along with their ability to slow fat absorption. Within that first minute of cooking, when the green gets even more vibrant, though, there's a slight boost in fat-blocking ability. So you can gauge thylakoid activity in both the grocery store and in your kitchen with your own 2 eyes. We have been chewing on leaves for millions of years, but today, the greenest thing about some people's diets may be a St. Paddy's Day pint. Americans have averaged fewer than 2 grams of spinach a day, not even half a teaspoon, but our bodies were designed to have thylakoids passing through our systems on a daily basis. So that delay in fat absorption we get from them can be thought of as our default normal state. It's only when we eat diets deficient in greens that we suffer the accelerated fat digestion that undercuts our natural satiety mechanisms. In the Journal of the Society of Chemical Industry, a group of food technologists argued that, given their fat-blocking benefits, thylakoid membranes could be incorporated into functional foods as a new promising appetite-reducing ingredient. Or you can just get them the way Mother Nature intended. Visit NutritionFacts.org/audio to see all the podcast episodes with descriptions that include links to their associated videos. Sources cited and other details are available on each video's page. Information about my books, How Not to Die, How Not to Diet, How Not to Age, is at NutritionFacts.org/books. All proceeds from book sales go to charity, and sign up for our free newsletter at NutritionFacts.org/subscribe to stay updated on the latest bite-sized videos and articles. NutritionFacts.org is a science-based nonprofit, and everything on the website is free. There are no ads, no corporate sponsorships, no kickbacks, strictly non-commercial, not selling anything, just put it up as a public service, as a labor of love, as a tribute to my grandmother, whose own life was saved with evidence-based nutrition. Thanks for listening.